In this lesson, we will explore multi-echelon inventory optimization, an advanced approach to managing inventory across multiple levels of a supply chain. This strategy helps organizations balance stock efficiently among suppliers, distribution centers, and retail locations to minimize costs and improve service levels. It represents a shift from managing inventory in isolation to optimizing it holistically across the entire network. Traditional inventory management often focuses on single echelon optimization, where each location or facility manages its stock independently. While this approach can work in smaller or simpler supply chains, it becomes inefficient in complex multi-tiered systems. For example, holding too much inventory at a regional warehouse might reduce stockouts locally but cause excess costs upstream. Conversely, insufficient stock at a distribution center might lead to shortages across multiple retail stores. Multi-echelon optimization solves these problems by analyzing the entire network simultaneously. At its core, multi-echelon inventory optimization, or MIO, aims to determine the optimal inventory levels at each point in the supply chain while maintaining overall service targets. It considers how inventory at one location affects availability and risk at another. This allows businesses to place inventory where it provides the most value, reducing total system costs without compromising customer satisfaction. Key inputs for MIO include demand variability, lead times, transportation costs, replenishment frequency, and service level requirements. Advanced mathematical models and simulations use this data to calculate optimal stock positions and reorder points across all echelons, from central warehouses to retail outlets. One of the major advantages of MIO is improved efficiency and reduced working capital. By redistributing inventory intelligently, companies can often reduce total stock levels by 10 to 30% while maintaining or even improving fill rates. This approach minimizes redundant safety stock and improves turnover ratios. Technology plays a crucial role in enabling MIO. Modern supply chain software uses real-time data, predictive analytics, and AI algorithms to simulate demand scenarios and optimize stock allocation dynamically. These systems automatically adjust inventory targets as conditions change, such as shifts in demand, supplier delays, or transportation disruptions. Cloud-based solutions also enable visibility across all echelons, ensuring coordinated decision-making. Another benefit of multi-echelon optimization is enhanced resilience. By understanding the interdependencies between locations, businesses can identify vulnerabilities and develop contingency strategies. For example, if a central distribution hub experiences delays, inventory buffers at downstream sites can temporarily absorb the impact without disrupting service. Implementing MIO requires collaboration across departments, including procurement, logistics, production, and sales. It also demands high-quality data and integration with ERP and demand planning systems. Success depends on aligning organizational goals, such as minimizing costs, maintaining service levels, and improving responsiveness with optimized inventory strategies. Real-world examples highlight its value. Leading global companies use MIO to reduce excess stock, streamline replenishment, and enhance customer experience. For instance, a manufacturer might use MIO to balance raw materials at plants, semi-finished goods at regional hubs, and finished products at retailers, ensuring smooth operations and efficient capital utilization. In summary, multi-echelon inventory optimization is a powerful approach that transforms how companies manage inventory across complex networks. By optimizing stock placement and interdependencies, businesses can reduce costs, enhance service reliability, and build more agile and resilient supply chains. As markets become increasingly global and dynamic, MIO stands out as a key capability for achieving operational excellence and competitive advantage.